Hello students, welcome you all to the session for solutions of GATE 2022 Engineering Mechanics subject with for a branch of mechanical engineering aspirants. Question number 1 from Engineering Mechanics. Two rigid massless rods PR and RQ are joined at a frictionless pin joint R. This is a frictionless pin joint. PR and QR are these points. Resting on the ground at a point P and Q as shown in the figure. The vertical force F acts on the pin R as shown when included angles are less than 90 degrees and the rod remains in static equilibrium due to Coulomb friction between the rods and the ground at a location P and Q. At theta at 90 degrees, impending slip occurs simultaneously at point P and Q. The ratio of coefficient of friction Q to that of P mu q by mu p is dash. This is the given figure. Now for this given figure, if I am drawing a free body diagram, see there are two links P and Q, right? This angle, let it be 90 degrees. There is a vertical force. There is a vertical force acting downward, F, right? And this be force 1. At the point P, we have two reactions, N1, theta 1. Here at Q, theta 2, mu N2, N2. This is the force F2. So obviously F2 and F1 taking theta at 90 degrees. Don't get confused of this. Now at point P, what happens? Resolution of all horizontal forces will be F1 cos theta 1 is equal to mu P into N1. Am I right? Mu into N1 it takes here at point P. And vertical force F1 sin theta 1 is equal to N1. Right? So when I equate these two, F1 cos theta 1 is equal to mu P, and what is N1? F1 sin theta 1. From here, F1 and F1 gets cancelled. Tan theta 1 is 1 by mu P. From this, F1 gets cancelled. Sin by cos is equal to 1 by mu P. Similarly, at Q, tan theta 2 will be is equal to 1 by mu Q, right? 1 by mu Q. Now, here the length is 12 meter and 5 meter. From here, if I take tan theta 1, if I take, how much it will be? Tan opposite by adjacent around 12 by 5. Whereas tan theta 2 will be reverse, which is 5 by 12. Am I right or wrong? From this point only I am writing it. So tan theta 1, tan theta 2 we know. Substitute here. Mu P is equal to 1 by tan theta 1 is 12 by 5. Mu Q is 1 by tan 5 by 12. Right? 1 by tan 12 by 5 is 0.4167 and tan 1 by tan 5 by 12 is 2.4. So mu Q by mu P 12 by 5 by 5 by 12 or 0.416, sorry, 2.4 by 2.4 by 0.4167. You will get a value of 5.76. 5.76. So he is asking you the ratio of mu p by mu q, that will be 5.76. 5.76. This will be the answer for the given question here. This is the answer for the given question. Any doubts? You can ping. Got it? 5.76. Moving to the next question. A structure along with the loads applied as shown in the figure. Self weight of all members is negligible and all pin joints are frictionless. AE is a single member that contains pin C. Likewise, B is a single member that contains pin D. Member GI, FH are overlapping rigid members. The magnitude of force carried by member CI is, right. What I'll be doing is, this is a bit a complicated joint. I'll do it by method of sections. When I cut this section vertically through E, for suppose in this way, the free body diagram is like, got it? And you have one joint behind it in this way. From point C, there will be force Fc1, the reaction force upward R, horizontal force H, downward acting force 4 kilonewton, 3 meter width, 2 kilonewton acting here. The distance is 1.5 meter, right? This is the condition. The point here is E. If I cut the structure vertically through point E, this is the free body diagram I will write. Summation of moment about E should be equal to 0, right? Force of 2 kilonewton into a distance of 1.5 meter plus 4 kilonewton to a distance of 6 meter and FCI in the opposite direction, that is minus FCI into a distance of 1.5 meter should be equal to 0. From here, please check FC1. Please check FC1. 3 plus 24 minus 1.5 FC1 equal to 0. From here, FC1 will be equal to 18 kilonewton. FC or FCI, I'm sorry, this is II. FCI is equal to 18 kilonewton. This will be the answer for the given question. 1 mark, simple question is this. Moving to the next question. A rigid uniform annular disc is pivoted on a knife edge A in a uniform gravitational field as shown, such that it can execute small amplitude simple harmonic motion in the plane of the figure without slip at a pivot point. Inner radius is r and the outer radius is capital R. Small r square is equal to capital R square by 2. Acceleration due to gravity is g. The time period of small amplitude simple harmonic motion t is equal to beta pi into root r by g, where pi is the ratio of circumference of the diameter of circle, then beta is equal to dash. Students, when we take this condition, this is pivoted at A, gravity is acting downward, right? So he has given small r square equal to capital R square by 2. Consider a point of mass hinged about this point. Let this point be O. Hinged point be O. Apply the torque method. Apply the torque method. What is going to happen? For suppose this is a pivot. Mass M is coming down. This is the radius of R, which is been shifted with some angle theta. The weight force is acting downward is mg. This theta is making with respect to axis y. So x axis, the base is r sine theta. In the y axis, it will be r cos theta. So this will be like theta disturbance. Downward force mg r sine theta, and that is written as I into theta double dot. So this equation is I theta double dot plus mgr sine theta is equal to 0. When theta is very small, sine theta will tend to theta. I theta double dot plus mgr is equal to 0. The task is to calculate I about the hinge, right? So I'll be use the formula from the centroid. I naught is equal to ICG plus MR square. What I'll do is, this was the circular wheel which is given to us. Consider a small elemental strip of dx. This elemental strip of dx, right? Unit at a radius of x. Take it at a radius of x. So mass is m by pi into r square minus r square into 2 pi x dx, whereas ICG will be r to r x square into dm. Now DICG at a point CG is m by pi into r square minus r square 2 pi x. What can I write this dx into? X square, right? That is 2m by pi square minus r square into x cube dx. ICG will be equal to r to r, smaller radius to upper radius, to differentiating I with respect to CG. That will be integral small r to capital R 2m by r square minus r square into x cube dx. X cube integration will be x power 4. Upper limit minus lower limit will be capital R power 4 minus small r power 4. 2m by capital R square minus small r square into capital R power 4 by 4 minus small r power 4 by 4. That gives you m by 2, take 4 LCM, cancel off, into r square plus r square on substituting. But he has given r square is equal to capital R square by 2, no? Now ICG is equal to m by 2 r square plus r square by 2. This becomes 3 by 4 mr square. So we know that I naught is equal to ICG plus mr square. ICG is 3 by 4 mr square plus m into r square by 2. This will be 5 by 4 mr square. Now you keep this I naught value in the above equation, that is I naught I theta double dot plus mgr equal to 0. We get 5 by 4 mr square into theta plus mgr theta is equal to 0. Theta double dot plus mgr by 5 by 4 mr square into theta will be equal to 0. We all know small r equal to r by root 2, no? Given, substitute back. Theta double naught, theta dot mg r by root 2 by 5 by 4 m into r by root 2 whole square shall be equal to 0. Theta naught plus omega n square into theta will be equal to 0. From there, if you write omega and compare it, mg r by root 2 by 5 by 4 mr square, you should get omega n should be is equal to root of 4 by 5 root 2 into g by r. This is omega n formulae. From there we know around t is equal to 2 pi by omega n, right? Substitute this omega n is equal to root 4 by 5 root 2. You will get t is equal to 2.66. Simple logic. Take t is equal to 2 pi by omega n. Omega n value is known to you. When you substitute, you will get 2.66. That is, beta value will be around 2.66. That is, you will get around t is equal to 2.66 pi into r by g. This is the condition. Pi into root r by g. Pi into root r by g. This is the condition. Here direct step as the place constraint I have did it. Pi value, t value is 2.66. Right? Bit complicated it looks, but it is very easy combination of 2 or 3 concepts. Moving to the next question. A cylinder mass of 1 kg, radius 0.15 meter, spinning at omega equal to 5 radian per second is placed in a horizontal flat surface. When g acts vertically downward, the coefficient of friction between the disk and the surface is finite and positive. Disregarding any other deception, except that due to friction between the disk and the surface, horizontal velocity of the center of the disk when it starts rolling without slipping will be dash meter per second. Right. Mass is given as 1 kg. Radius is 0.15 meter. Right. It is rolling. So obviously, surface omega, mass is 1 kg, radius is 0.15 meter. We have some omega and some radians, and there will be condition like this. Now I can clearly write this equation. F into R shall be equal to I into alpha. F into R is equal to I 1 by 2 into mass 1 into R I don't know into alpha. F is equal to R alpha by 2. Now we all know F is equal to MA. A is equal to R alpha by 2. Just after hitting the ground, I am taking this. Just after hitting the ground. From here, I'll write final velocity is equal to initial minus alpha into t. Vf is equal to V naught plus At. V naught initial 0. Vf is equal to rotational component acceleration r alpha by 2 into t. Vf is equal to r into omega f. R into omega f is equal to r alpha by t or r alpha by 2 into t. From here t is equal to 2 omega f by alpha. R gets cancelled and this will be the value of t. Substitute back now. Here what will you substitute? Omega f equal to omega naught minus alpha into 2 omega f by alpha. That is, take the LCM. 3 omega f is equal to omega naught. Omega f is equal to omega naught by 3. So finally final velocity is r omega naught by 3. R is 0.15, omega naught is 5 by 3. Right? This is the condition, no? That's why parallelly I am substituting. You will get around 0.25 meter second. Meter per second. 0.25. Simple question. 1 mark question this is. An elaborated explanation. Hope you people have clearly understood. Moving to the next question. A plane of the figure represents a horizontal plane. A thin rod at rest is pivoted without friction about a fixed vertical axis passing through O. Its mass moment of inertia is equal to 0.1 kg centimeter square about O. Mass of 0.001 kg is normally at 200 centimeter per second at the location shown and sticks to it immediately after the impact. Angular velocity of the rod is dash radian per second. Basically, this is the mass which he has given with certain velocity and the distance is 10 centimeter. Angular momentum of the system will remain same at O, right? So, initial and final momentum if we take is same. M into V into R should be equal to I into omega, right? I is nothing but for system. M 0.001 with velocity 200 centimeter per second into a radius or some distance of 10 is I of the rod and you have I of the particle moment of inertia, right? Into omega. These all are being taken from the point O. That is equal to this you will get 2 0.1 plus 0.001 because he has given clearly in the question moment of inertia here into 10 square into omega. From here calculate omega. From here calculate omega. If you calculate omega, you will get 10 radian per second. Simple 2 marks question. 1 mark questions are a bit lengthy, 2 marks questions are very easy. I have equated the momentum of the initial and final MVR and I naught into omega. I, we have two conditions here, that is moment of inertia which is 0.1 about O and the point of mass of 0.001 kg which is hitting normally at 200 centimeter per second. So omega is 10 radian per second. Answer is 10. By this, we have completed the solutions for engineering mechanics, mechanical engineering branch GATE 2022. Hope you people have understood, students. Thank you.